Welcome to Rational Numbers, Adding and Subtracting Fractions number 2, where we no longer have common denominators. So if you're like, that scares me way more than it should, you might need to go backwards and check out the number 1 version of this, where we talked about how to simplify and reduce and convert. That doesn't say convert. And convert from mixed numbers to irrational fractions. And if you're like, whoa, that sounds crazy, this is actually super ultra important. In fact, it's so super ultra important, it's going to show up here and here and here and here and here and here and here. So we won't dive into those just yet. We'll dive into number 1 and number 2, and then I plan on doing the rest of these. This was the notes portion. This is your actual assignment. So let's get started. Number 1, 5/6 minus 7/12. All right, right now I'm in trouble because these guys are not the same. And if you're like, well, who cares? They have to be the same. Otherwise, these cannot be added or subtracted. Now, if you're like, but yeah, you can when you multiply or divide. Yeah, boy, we didn't say anything about multiply or divide. We are subtracting right now. So I'm going to give you 2 methods. There is the 100% works every time method, and I don't love it, but it works. So the reason that, and here, I'll go ahead and give you a preview of the other one, and the other one is least common multiple. This one I like, but it requires a little bit more thinking. So some of y'all are like, sign me up for 100%, here we go. So how do you do the 100% method? You take this denominator and you multiply it over here. Just like this, 12 over 12. You take this denominator, you multiply it over here, times 6 over 6. Now pause for a second. How can you multiply something by 12 over 12 and it actually be the right thing to do? Well, I will tell you right now. 12 over 12 is equal to, here, zoom out. 12 over 12 is equal to 1. If you have 12 friends and you have 12 cookies, everybody is getting 1 cookie per friend, right? Here's the thing about that. We can use this to convert and simulate the crowds getting bigger. So what we could do is if we multiply this by 2 over 2, that would be like, what if I had 24 friends and 24 cookies? Well, guess what? They're still getting 1 cookie per friend, right? And we could continue going. We could be like, you know what if we multiply this by 10 over 10? Well, now that'd be 240 people and 240 cookies, and guess what? It's still 1. So that's why right here, when we multiply by 12 over 12 and 6 over 6, we're not technically doing anything. We're just simulating what would it be like if we had this. So 12 times 5 is 60. 12 times 6 is 72. 7 times 6 is 42. 12 times 6 is 72. Check it out. We have the same denominator, and we will be subtracting because there's a subtraction sign in between them. When we subtract, we get 1870 seconds, which is not my favorite, but if we can divide both of these by 9, because I'm telling you we can, we get 9 times 8, 2/8. Oh man, we could actually divide this by another 2. So 18 actually went into both of those, you get 1/4. Okay. That wasn't awful, but now let me compare directly the least common multiple method. You have a 6 as one denominator. You have a 12. You have a 12 as one the other. If you were to multiply them both by 2, you get 12 and 24. If you multiplied by 3, you would get 18 and you would get 36. If you multiplied by 4, you get 24 and you get 48. And I'm going to stop there for a couple of reasons. 1, I'm getting down here in this stuff and I don't want to confuse you. 2, that's a lot of numbers and I don't want to confuse you. And 3, I see that they have a common multiple here. I see that they have a common multiple here. They have many common multiples, and the least common one is actually kind of the easiest to work with. So check this out. I'm going to erase all of this, and I'm going to use the least common multiple approach. In fact, I'm going to erase all of this, because why would we want to go further than we really need to? So what's going to happen is I'm going to multiply this guy by absolutely nothing, because, oh, I'm just kidding. I'm going to multiply this guy by absolutely nothing, because 12 is our multiple, right? So I'm going to multiply this one by 2 over 2. Why 2? Because if I multiply 6 by 2, I get 12. So I now get 10 twelfths minus 7 twelfths. How'd I get that? 2 times 5 is 10. 2 times 6 is 12. 7 twelfths didn't change. Check this out. 10 minus 7 is 5. Okay, I don't know what happened to me just there. 10 minus 7 is 3. 3 twelfths. I divide both of those by 3 and I get 1/4. So let's be honest. Did you like this one, or did this not seem so bad? Hopefully you saw that that didn't seem so bad. If you don't agree with me, here's one more where the 100% and the least common multiple are the same thing, because we get 3, 6, 9, 12, 15. I'm going to stop there for no apparent reason. 5, 10, 15. Oh, look. 15 is the common multiple. Times 1 times 2 times 3 times 4 times 5. So I'm going to have to multiply 3 by 5. Notice how that's each other's denominators. And I get 10 fifteenths. I'm going to have to multiply 1/5 by 3. Why? It's not just because it's this denominator. It's because 3 times 5 is 15. So I get 3 fifteenths. This answer is now 13 fifteenths, and we're done with that one. Definitely not as bad as the first one, because the numbers don't get so large and ugly, but hopefully you see the comparison. Now, we are jumping into several in a row where we need to convert. Convert from mixed numbers to, if you can't read that word, it's tough to read. Convert from mixed numbers. Let's try it again. Convert from a mixed number to, you know what? It just occurred to me. I wrote over here to convert it to an irrational number. Bro, it's not irrational. It's improper. So if you've been like sitting here freaking out thinking I'm like, he doesn't know what he's talking about, my bad. I used the wrong E word. So convert from mixed number to an improper fraction. Here we go. Let's do this. 7 1/3 is a mixed number. To convert this to a mixed number, it's a mixed number. To convert it to an improper fraction, we multiply. 3 times 7 is 21. We're now going to take 21 plus 1 and get 22 thirds. Same thing here. 4 times 1 is 4. 4 plus 1 is 5 fourths. Don't forget this negative. 22 minus 5 is not what we do next, because we don't have a common denominator yet. Man, I am like rushing in my head, and y'all are paying the price for it. So, least common multiple, 3, 6, 9, 12. 4, 8, 12. Why am I doing that? Because 3 and 4, right? 3 and 4. So, what is our least common multiple? Would be 12. So again, this is technically the works 100% of the time method, where we multiply this one by 4 over 4 and this one by 3 over 3, just a coincidence. So we get 88. Let me just double check my math. 3 times 7, 21 plus, 22. 88 twelfths minus 15 twelfths. All right, 88 minus 15 is 73. 73 twelfths. That can't be reduced. It's not divisible by 2 or 3. Definitely not divisible by 4 or 5 or 6, 7, nor 8, nor 9, nor 10, nor 11. I think you get the idea. It doesn't divide. So I'm going to see How many times is 12 going to 73? Well, with that, I'm really just going to like multiply in my head, and it's 6 times. So this is 6 and 1/12. Now, I don't know if you saw that coming, given that this was 7 and 1/3 minus 1 and 1/4. Maybe you could see it now, but back up here, I don't know how accurately you would have gotten this. In fact, I technically didn't write the right answer. I left a 1 out. 6 and 1/12. Number 4, I'm going to convert because these are both mixed numbers. 4 times 1 is 4. And then 4 plus 3 is 7/4. 3 times 10 is 30. 30 plus 9 is 39/10. This is looking a little ugly, but we can do this. So 4, 8, 12, 16, 20. Well, I think you can see that the common multiple is going to be 20. In fact, you might have not have even had to do any of this stuff over here, but let's say maybe you had to. So we have to multiply 4 by 5 in order to get 20, and we have to multiply 10 by 2 in order to get 20. So here's the 2 over 2. Here's the 5 over 5. 5 times 7 is 35/20. 39 times 2, you might not know how you can do this in your head, is 40 times 2 is 80. Didn't have to write that out, just communicating visually. And then if we just subtract the 2, that's how you'd get 39 groups, because we're taking out a group of 2s. So that would be not 30, that would be 78/10. And what are we doing all along? We are subtracting. So let's subtract. Well, as I look at this, I have received 35 compliments. That's great. But I'm about to receive 78 insults. So I know I'm going to be feeling negative. So here's what I'm going to do. 78 minus 35 to get, come on, hang on, there we go. To get 43. 43 will now be negative. Now I know this doesn't say that, but this does. Negative 43/20. By the way, I forgot to write my 2 right here. I'm having a rough day of recording here. Next, convert it to a mixed number. 20 goes into 43 2 times with 3 left over. Done. So I believe we've reached the part of the video where you could hit like ×2 speed, because I think you get what's going on now. 12 times 4 is 48. 48 plus 11 is 59/12. Yikes. And 1/9 is just 1/9. But we need a common denominator here. So 9, 18, why can't I do math right now? 27, 36. I'm going to stop there because I know that 12 is 12, 24, 36. So here's what we have. Times 1, times 2, times 3, times 4. So for 9, I need to multiply it by 4 over 4. And for 12, I need to multiply it by 3 over 3. And if you're like, that seems awful, what would be even worse is multiplying by 12 and 9, if you ask me. So here we get 4/36. Here's one where it would be helpful if I could do the math. What about 60 times 3? That's 180. And if I subtract a group of 3s, that's 177/36. Wow. And I'm adding, right? Okay. Well, so I'm pretty sure you could have seen that this was going to get larger, but would it be more than 5? Or would it be under 5? Well, let's find out. So 177 plus 4 is 181/36. Well, so can this all be divided? 181 cannot be divided by 2 or 3, 4, 5, 6, 7? Nope. 8, 9, 10. It can't be divided by any of those. So here's what I'm going to do. Let's just do this. 181 divided by 36. And let's just start guessing through this. How about 5? 36 times 5. That's 30. That's 180. So check this out. This is 5 and 1/36. So when I said a second ago, is this going to be bigger than 5? I wasn't 100% sure. Look how much it's over 5. That's a teeny tiny amount. 36. If you think about it like a calendar, there's 31 days in a month. Well, a 36th would be like picking, even more rare than picking one random day in the month, right? And if you don't know what I mean, 136 is small, okay? So 5 and 136 is there. 1 and 1/8 plus 1 and 1/6. Okay, let's take a moment and say on some of these problems, on some of them, we don't actually have to convert from mixed number to improper fraction. But you need to be able to tell the difference. This is one where we can take the 1 and the 1 and make it 2. And then just add 1/8 and 1/6. We could, all right? And then we could do this thing where it's 8, 16, 24, 6, 12, 18, 24. Oh, look, this is times 3. This one's times 4. Times 3 over 3 times 4 over 4. 3 24ths plus 4 24ths is 2 and 7 24ths. We could do that. We really could. Because here's the difference. We could, if we had converted it to improper fractions first, this would have become 9/8. And this one would have become 7/6. Then you multiply by 3 over 3. Then you multiply by 4 over 4. And you would get 27 24ths plus 28 24ths. Well, guess what? That is 55 24ths. And 24 can go into that 2 times. 55 minus 48, which is what that is 7 24ths. Yes, this one was probably faster and easier. But can you do that on all of them? Can you do that here on number 8? No. I would not recommend it. I would not do -1 plus -1 and then just 3/5 plus 1/12. Don't do that. If it's simple as just addition, maybe you can do it, okay? Number 7, 1 and 5/9. We can convert this to 9 plus 5 is -14/9. This is just regular old -2/3. No big deal. I'm going to multiply this by 3 over 3. I have now gotten to the level where I'm just going to tell you, hey, you can multiply it by that. But if you're like, I'm not at that level, Mr. McMath, so then here's what you got to do. They're the multiples of 9. I'm stopping there because this one is 3, 6, 9. Oh, look. There's the least common multiple. You have to multiply 3 to get that. So look, triple check. There it is. -14/9 minus 6/9 is -20/9, which is -2 and 2/9. Number 8. Let's convert to improper. 5 times 1 is 5. 5 plus 3 is 8, and it is negative. 12 times 1 is 12. 12 plus 1 is 13/12, and when you add a negative, that is subtracting. So I'm just going to make that negative right there. The least common multiple here, let's see, 5, 10, 15, 20, 25, 30. And then over here, 12, 24, 36, 48, 60. So yeah, we will run into one, and this is one I kind of knew what was going to happen. So it's a little unfortunate. This is one where we're going to have to do like that, what I called the 100% method of we multiply this one by 12 over 12 and this one by 5 over 5. How come? Well, because there's 60 and there's 60. Nothing else is going to end in a 0 or a 5, and that's all that 5 ends in. So let's get rid of all this over here just so we have a clean place to work. Hurry up, eraser. There we go. So we end up getting -96/60 and 65/60ths. And when we combine that, let's do this, 65 and 96. We're going to add them. Why are we going to add them? Because if I'm feeling negative 96 and I'm about to get more negative, we're just going to be combining these things. So we end up getting 161 negative 161/60ths, okay? And that is going to go into, 60 is going to go into 161 twice. So watch this, 161 minus 120. Why 120? Because 2 times 60, we get 41 60ths. And that's the final answer because there's no more left to happen. 41 is prime. Can't be divided by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You get the idea. Number 9. What is this? Negative 2? Well, guess what? We can write that as negative 2 over 1 minus, not minus. If I have a subtraction, if I have 2 negatives like that, that's adding. So negative 2 over 1 plus 3/8. Having over 1 is beautiful because all we have to do is multiply it by the other denominator, and then we're ready to go. So on the left, we have negative 16/8 plus 3/8. This is negative 13/8, which if we were to rewrite as a mixed number is negative 1 5/8. Now, some of you out there might have been like, Mr. Math, I could have done this. I could have got there just kind of by thinking about it, right? Like if you're on a number line and you were at negative 2 and you were asked to go in the positive direction, 3/8. Well, you might have been like, well, listen, there's 1, 2, 3, 4, 5, 6, 7. Let's see, 1, 2, 3, 4, 5, 7, 8. There's would be 8. Anyway, the idea is that this is like negative 1 7/8. This is negative 1 6/8, etc., etc. Well, I guess I don't have to do etc., etc., because the next one would be 5/8. So if I went 1/8, 2/8, 3/8, I'm at negative 1 5/8. Okay, if you were capable of doing this, then you are not the person that I'm talking to that says we must convert from mixed number to improper fractions. Last one. 6 times 2 is 12. 12 plus 1 is 13. 9 times 1 is 9. 9 plus 2 is 11. And check it out. Negative is positive. So what we can do here, let's see. 6, 12, 18. Aha. 9 and 18. We multiply this by 3 over 3 because there's times 3 to get 18. And we multiply this by 2 over 2 because it's times 2 to get 18. We get 39/18 plus 22/18. Let's see, that's 61/18. And if you're like, ooh, that seems awfully awful, I kind of agree with you. I am trying to think, okay, let's, to help ourselves kind of round here, because we're just kind of trying to estimate, what if we called that 20? How many times does 20 go into 61? How about 3 times? Yeah, it definitely does, right? So let's do this. 18 times 3, that's 24. Carry the 2 right here. 3 times 1 is 3, so we get 54, okay? If you're not following why I'm doing this, I'm trying to see how many 18s are going into 61. So I estimated using 20, and I said, oh, well, 3 times. So then I figured out how much that is, and then I'm doing this subtracting here to go, oh, there would be 7 left over. So it is 3 7/18. So there's the questions here. Or I'm sorry, this is all the examples here. The big news is if you're not sure how to do this stuff, then the thing that's going to work is going to be convert from mixed numbers to improper fractions. Obviously, you don't have to do it all the time because those are not mixed numbers. But if you need help, please let me know.